Divided by a monomial or a single term. And some of you figured this out yesterday already, which is good. Remember, when we multiply, you don't have to write this, but if I said 4x times 5y, we multiply the coefficients, which represent the numbers in front of the x and y. So 4 times 5 is 20. I still got a times x, I still got a times y, so 20xy. Dividing is the inverse of multiplying. So if you think about it, what would you do to the coefficients here? The numbers in front. What did you do to them, Zara?
We just divide them.
Yeah, and you divide them. So we divide 10 by 2. And then we can divide z by z. And remember, those are being multiplied together. So I just kind of split it up. 10z over 2z is the same as 10 over 2 times z over z. Well, 10 divided 2 is 5. And z divides z. Not 0. Z minus z is 0. What's anything divide itself? 1. Right? Or we can reduce it. Divide the top and bottom by z, you get 1 and 1. So I get 5 times 1, which is just 5. So notice in here, if we've got a variable and an identical variable on the top and bottom, they can reduce to 1. And then we don't have to write the 1 in. So this one, well, divide the coefficients. What do you get? -5. What happens to the a's? They cancel each other out. But what's still left on top? A times b. Done. Now this one, we haven't talked too much about this. But if you look at the numbers, you should be able to see, well, you know what? That's not going to give me a nice number when I divide -3 by 4. So I'm thinking about pulling out my calculator and going to decimal. You don't need to. Whenever you divide two numbers, if they don't divide cleanly, leave it as a fraction. So 1 divide 2. Don't change it to 0.5. Just leave it at 1/2 and make sure it's reduced. 5 divide 9. Can't divide it cleanly, so leave it as 5/9. 6 divide 10. Well, it doesn't divide cleanly, so leave it as 6/10, but this one has to be reduced. To what? Yeah. Don't go to decimal. Leave it as a fraction. So when we do -3 divide 4, that's not going to divide cleanly, so leave it like this. What happens to the p's? Q's. Both of them do, so I'm not left with any variables. Done. So we saw when dividing a single term by a single term or a monomial by a monomial, divide the coefficients. Those are the numbers in front. Cancel out. Identical variables on the top and bottom. And then multiplied any remaining variables. So what I mean by that, you can look at B, divide the coefficients to get -5, cancel out any identical variables, which are the A's, and then multiply any remaining ones, so I have to times B. Don't need it. Okay. So, just a little problem here. Okay, I don't know why I did that. What the happened here? What is that? There. What? Go away. Let's. There. There, finally. Okay. So the area of a rectangle is 25xy. The width is 5x. You have to figure out an expression for the length. Well, what if I said this? Let's just do one that has numbers. No, you don't have. What's the length? Yeah, because 5 times 5 is 25, right? Or we can find the length by taking the area divided by the width, 25 divided 5. So in this problem, it's 25xy and 5x. So to find the missing length, I take the area 25xy divided by the width, which is 5x. And what do you get? 5y. 25 divided 5 is 5. X is reduced out or cancel out. There's still a times y. Okay. One last thing with dividing. What happens if we divide more than one term by a monomial? Well, remember this, you don't have to write this down. Remember this from multiplication. How would you multiply? What would, yeah, okay, I see you guys doing that. You multiply the 2 by everything inside. 10x plus 14. How would you think you'd divide it? Finley? Yeah, divide everything up top by 2. So it's going to be 6a divided 2 plus, and then 12 divided 2. It's just, we're going in the reverse order. 3a plus 6 is the answer. Okay, so whenever you see a division question like that, you're going to do more than one division. You got to divide everything up top by 2 in that question. Here, Okay, instead of writing it out like that, I'm gonna have to divide 15AB by -5 and -5C by -5. Yep,
Is it 3AB plus C?
correct. 15 divided -5 is -3, and there's still a times AB.
Can you write that out as well?
Oh, sure. Oh, no, that's okay. We do it like that. And then we do it like that. Yeah. And then we've got two negatives here, so it changes to a positive. That's why we get plus C. And a couple more.
What about just
Did I miss one?
the, take out those lines?
Oh, sorry. Yeah. Yeah. So when we divide a polynomial, more than one term, by a monomial, divides each term on top by the expression on the bottom. So like if there's two terms up top, I know I have to do two divisions. If there's three terms up top, I know I have to do three divisions. So these last two examples, there's three terms up top for each one, so I'm gonna have to do three divisions. And again, you can either circle them, just to remind yourself you have to do three divisions, or you can write them out. 4xy divided 2x plus 8xz divided 2x minus 12xa divided 2x. So when we do those three divisions, what do we get?
It's like we're at for the fourth of Z, minus 6A.
That's right. 4 divided 2 is 2, those go, we're left with a y. 8 divided 2 is 4, x's go, we're left with a z. 12 divided 2 is 6, x's go, we're left with an 8. Now, this one, sometimes students will make a mistake. So let's write it out. It's going to be -3 divided -3 plus 15mn divided -3 minus 21n squared divided -3. This is where students make the mistake. What is this? 1, not 0. It doesn't disappear. It's 1. It's still there. And now let's do the rest of them. Well, we've got a plus divided negative, so that's going to give us minus 5mn. We've got a negative divided negative, that's going to give us positive.
And squared.
Got it. Okay. Good. Okay. So I'm only going to assign